We're continuing the lab for week 2. In this lab, we're talking about normality and outliers. So we've been talking about why we need to assess for normality. That is, it's a common assumption of most of the statistical techniques that we're going to be using. Um, and there's many different ways to do that. A lot of them are very subjective. And so now we've looked at some more objective approaches, looking at some of these statistics. Here, there's a couple other popular tests that are sometimes used, the Kolmogorov-Smirnov test and the Shapiro-Wilk test. And you can run these with an SPSS, it's fairly straightforward, and it generates a table that looks like this. And so these are two different variables. This one is extroversion, this one is depression. So we're testing the distribution of two different variables here. Two different tests basically assessing for the same thing. So this is the extroversion variable being tested by the Kolmogorov-Smirnov test as well as from the Shapiro-Wilk test. Then this is the depression variable also being assessed by those same two tests. We haven't talked about statistical significance yet, so don't get too hung up on this. But basically, if you look at this SIG column, significance, I'll just say if this number is below 0.05, then it's considered not normal. If it's above 0.05, we would say that it is normal. So extroversion, based on both of these different tests, they both agree that this distribution is not normal because it's less than 0.05. The depression variable, though, look, both of these are above 0.05, so we would say the depression variable is normal, the extroversion variable is not normal. So this is one more approach. So we'll see when we get into the assignment, the classwork, I'll show you how to conduct each of these tests in SPSS, and you'll see that sometimes they agree with each other, sometimes they don't, and as the researcher you have to make that judgment call. Let's say something about outliers. An outlier is a score that's very different from the rest of the data. Sometimes you'll hear them referred to as an extreme observation. When we analyze the data, we have to be aware of these values because they can bias the model that we fit to the data. They basically can render our conclusions inaccurate. Outliers increase the variance in a distribution. So we know about variability, right? It's your standard deviation. If you throw outliers in there, the standard deviation is going to go up. And what that means is it will be harder to detect real differences between samples. So when we get into t-tests and things down the road, you'll see what I mean by that. But basically, the more error, the more variation there is, the harder it is to kind of detect differences. It can affect how correlations look. We run a correlation test. We'll get into that in I believe it's week 5, a little later in the class. So if you have an outlier, it can create the impression of a correlation that doesn't exist, or it can mask a correlation that does exist. We'll see that down the road. And also, it can make a sample seem much higher or lower than it really is because it influences the mean quite a bit. So outliers are important to be aware of. Again, you want to inspect for these things right away, these different descriptive statistics, distributional characteristics, outliers. A lot of people will overlook this step and they'll go right into the more interesting part of the analysis and oh, I found this conclusion, this finding was so great. Really, it's simply an artifact of an outlier, and it's completely wrong if they don't even notice that. So they might publish some material that's completely inaccurate because they didn't check for outliers. What causes outliers? Well, there's different reasons why an outlier might exist in your data. One common reason is they typed it in wrong. When you run a study, a lot of times the data aren't immediately computerized. You have to type it in by hand. So I recently ran a survey, surveyed 100 high schoolers, and the survey had 100 questions. So that's 1,000 data points that have to be entered. 10,000 data points that have to be entered into the computer by hand. And that's an enormous amount of work, and just think about how easy it would be to accidentally type the wrong button. So by looking at outliers, by looking at the distributions, it's one way to catch mistakes. You might not catch the mistake that way. If it was supposed to be a 3 and you put 4, you may not notice it. But if it was supposed to be 3 and the next value was supposed to be 4, but you accidentally type 34 all at once, that might really stand out. It's a very unusual observation. It's not uncommon for data entry errors to occur. They're very common. Whenever it's possible, it's good to use a computerized scoring system. So I had did some others, another survey before that one with college students, and it had 200 questions. And I was surveying about 100 students, so 20,000 data points. But I was able to use a Scantron. They were older and they were able to handle that, and as a result, the computer could score it, and there were basically no errors. So that's one problem. Another reason we can have outliers is because even though the data were entered correctly, they're still wrong. So sometimes people will just lie. Um, for example, let's say some health organization is surveying junior high kids, and they're asking them about their drug use and sexual behavior. Um, it may not shock you to know that occasionally middle school students will lie because they think it's funny. So maybe you'd ask them how much alcohol, how many servings of alcohol they consume in a day. And in reality, they don't drink alcohol at all, but they think it'd be funny to say that they consume 10 servings of alcohol a day. So now you're the researcher thinking, oh my goodness, here's this kid that drinks all this alcohol. I'm really concerned about the future of our country. This child is our future, and he's just messing with you. So that's another reason you might have an outlier. And then another reason would be that the observation comes from a different population. So you might have an interest in one population and someone else sort of snuck in. So maybe you're looking at a standardized, some kind of academic test, maybe a reading test, and then now you have this student with a severe reading disability. So maybe you're looking at how quickly they read, and it ranges from maybe 80 words a minute to 150 words a minute, and now you have this person at 5 words a minute. And it is entered correctly, and it actually is accurate, but this person isn't from the population you're interested in. So you might say, you know what, I'm not interested in people with special severe reading disabilities. I want typically developing children. So that's another reason you could have an extreme case. How do you detect these? Well, one approach, common approach, is to informally detect them through a visual inspection of a histogram or box plot. So if you think about when we looked at the shape of the distribution, looked at histograms, we'd say, well, it's approximately normal. It's just kind of a similar idea. You're looking and saying, well, that looks kind of unusual. And again, it's not terribly technical. A more scientific way to detect outliers is to look at standardized values. So in the reading and in the lecture portion, you learned about z-scores and standardization. And basically, to get a z-score is you take the observation, you subtract the mean, and divide by the standard deviation. And that basically gives you a value in standardized units that tells you how far away from the mean that observation lies. So a lot of times people will say, well, if it has a z-score, absolute value above 3, or they might give a different criteria. I use 3 most of the time. Then it's very unusual, very, very unusual, and we'll consider that to be an outlier. And maybe you'll remove it from the data set possibly. So, so that's kind of a more technical approach. Again, you have to decide beforehand what constitutes an outlier. So if you say, well, I'll delete anything over 3 or under 3, fine. But you can't change your mind later because then that can bias your results. So, for example, let's say you're trying to detect a relationship between two variables of interest and there's an outlier. Well, if the outlier falls in line with your theory, then it's going to make the correlation seem much higher. You might say, well, an outlier of 3 isn't so bad after all. Let's just keep it. I'm sure it's fine. But then again, if it goes against the pattern you want to detect, something unusual, and it's basically making the correlation disappear that you wanted to have there, and it's an outlier as a z-score of 2.5 or 2, you can say, well, 2, that's really high. I don't know if I want that outlier. I'll delete it. So you can see easily how you can start to bias your results by picking the outliers you like and leaving out the outliers you don't like. So you have to decide ahead of time. This is my criteria. I'll follow it no matter what, even if I don't like the results. That's more scientific. How do you do that? We do that in SPSS. I'll show you this later. But basically, when you run your descriptives, you just pick the variables you're interested in and just click this box right here, Save Standardized Values as Variables. And this is going to create a new variable. So when you look, I'll show you later, but you'll look at your variable view and you'll see a whole new line, and it starts with a z, and that means it's the z-score of that variable. So what do you do when you find them? Well, it kind of depends on the reason for the outlier. If it was just typed in wrong, then you would simply fix it. Um, so especially the case if the value does not make sense given the unit of measurement. So if it's IQ scores and you have a 13, well, there's no such thing. That's not even a realistic value. So you know it's wrong. If you can go back and look up the original test and fix it, fine. If you don't have it anymore, this is all you had access to, you know for sure it's wrong, it wouldn't make sense to leave it in at 13. You have to take it out or find some other way to address it. It's like an imputation technique. Treat it like missing data. But it would not make sense to keep an IQ score of 13 in your data set. It's clearly wrong. If it were 130, it might be really on the high side, but it's still a realistic value. Then it's harder to decide whether to keep it in or not. Um, uh, if if it is realistically plausible, then you have to decide, is there an easy explanation for why it's still so unusual? So um, was the test scored correctly? Did they lie on the questionnaire? Did they get confused and mix it up? Um, and then you might ask, does this participant actually come from the population of interest? Is this person someone I'm even interested in? Do they even belong in here? So if you were surveying ops students and someone brought their kid to class because they couldn't get a babysitter or something, and now there's a 5-year-old and they answer your survey and the results are really unusual for this kid, you might say, well, I didn't want to survey 5-year-olds. They weren't even supposed to be in there, so it would make sense to throw out that data. Um, Only delete the outlier if there is a really legitimate methodological reason for doing that. So don't delete it just because it doesn't fit with your theory. And that's so tempting to do because you got your data, you've worked so hard on this, and you take a look at it and you realize there's this one value and it's unusual and it's ruining everything. It's making your results non-significant when you want them to be significant, and they would otherwise. You'll understand what that means later. Um, and no one would know. You could just change it or push that one little delete button and not tell anyone, and voila, your findings are great. The problem with that, other than the fact that it's dishonest, is that you might miss out on some really keen scientific discoveries. Why does this person break from the norm? Why is this person so different than everyone else? If you have access to these participants, you might even be able to chase this person down and ask them, "Hey, I noticed that your response was different from everyone else's. What happened? What was the reason for that?" An example of that from my own research, a couple years ago, I was looking at people's perceptions of how much control or influence classroom teachers have over their students' outcomes. So, does when kids come in the classroom, does the teacher really have that much control over how well they do, or is it sort of up to fate, or up to the parents, or up to some sort of outside source? And some people believe that teachers really have a lot of influence over how well the students perform, and others don't. And I was interested in people's opinions on merit pay. Should teachers get paid more if their students learn more? And so the pattern I saw was that in general, people who felt that teachers had a lot of control over the situation, they thought that the teachers should get paid more if they were successful. So you have the ability to do this. If you do it, you should be rewarded. Well, I found one person who he was a teacher. He was a high school teacher, and he scored the highest on this measure of how much control he thought teachers had over the students. Because the teachers have an enormous amount of influence. They can basically make or break a student's success. And when we asked him, do you believe in merit pay? He said, absolutely not. Absolutely not. And he was the only one who broke from that norm. So it would have been easy just to say, well, this guy's a weirdo, I'll leave him out. But I followed up and I asked him, his name was Aaron. I said, Aaron, why do you believe this way? You're different from everyone else. Why don't you believe in merit pay if you think the teachers have so much control? And he said that, to be teaching is a calling. It's a spiritual calling. And if you're not doing everything in your power at every moment to help your kids succeed, well, you're a repulsive human being. It's too important. Why aren't you already trying your hardest? If getting paid more causes you to try harder for your kids, then you're basically a terrible person. So he had this sort of different view, and I thought that was interesting. I was able to have this new finding because I chased down this outlier. So anyway, hopefully that is helpful. If you have any questions, let me know. after this, I'll walk you through how to complete the classwork assignment.